Good afternoon, everyone. I'm presenting Group 6. My name is Manish, and these are my teammates, Shyama, Diptesh, and Muskan. So our project was optimizing ethanol by fermentation. As we move further, I would discuss each and everything, and I will try to not confuse you more, and I will keep it as simple as possible. So our project objective. The objective was to produce ethanol or to enhance the process of ethanol with the use of different concentration of sugars, different yeast, and combination of yeast plus nutrients. And there are too many samples, so that's why I just told you that I will keep it as simple as possible. So why the interest? The interest of this project was something, but first I will discuss about what is fermentation. The process, it includes yeast. Yeast are some microorganisms which eats sugar and converts them into alcohol, which is further gives it takes very less time as compared to corn. So if I compare our project with something, then I would compare it with the corn, because first the proposal that we did was producing ethanol by using corn, but Professor Margaret told us that it will take a longer time, which was not our preparation was not fully done. We didn't see the time interval when we proposed our proposal. So after that we came to know that ethanol and production of ethanol can be done by yeast as well, which take very much less time, and we can do many different combinations which can be very helpful in biofuel industry. So this was the main interest, to increase the production of ethanol without corn and using the yeast. So the first thing that can help us is increasing ethanol yield. So the basic thing is that sugar, glucose, lactose, any kind of sugar that are very cheap in cost as compared to corn. The second thing is the process time. The glucose can be ready to use. Like if you just have to make the sample combination and you're good to go. You just have to take the readings, your measurements, whatever you want to take. That I will discuss further. But the main thing is about the time interval. So for the corn thing, if you want to use corn for the process of ethanol production, the corn has to go through 3 days of process, which includes purification, cutting, and mixing it with different chemicals, which brings it up to a particular concentration, after what you can use it to produce the ethanol. But it is not in compare with the yeast. Yeast and sugar are ready to go samples. You just have to mix it again, the same thing. The increase in ethanol yield. After Shyama goes with the statistics, you will come to know that the percentage of yeast produced by our process is more as compared to the corn thing. So if you use the same amount of corn and same amount of yeast, you will get more concentration of ethanol in yeast plus sugar, but not in the corn. Lower cost. Again, I told you, corn are more costly. We have to go through the process. So first you have to buy it for a high price, and then the process thing also takes charge to process the corn. But for yeast, it's easy, very easy. So I will talk about our work plan. So I have divided our work plan in phases, because there were this journey of the Capstone for the optimization of ethanol has been a roller coaster. There were something which we added in the middle of the project which we didn't even thought about, because that was a great help by Ms. Margaret, because it really helped us to make combinations and compare it on a high scale industry levels. So on the first time, phase 1 was the literature, as the previous group talked about, that we did the safety check, safety protocols and everything. That was the phase 1. The phase 2 was the sample preparation. So when I talk about the sample preparation, in total we prepared 3 sets, but for the phase 2 there were just 2 sets. I will give you a brief information. The 2 sets were, one was with yeast and sugar. The second one was yeast plus nutrient. And I would like to mention this because further it will make more confusing. The yeast and nutrients that we made in these 2 samples were of different companies. They were both of the yeast and nutrients were organic. They were not artificially processed. So these were 2 samples in the phase 2. Talking about phase 3, it was a sample of turbo yeast. Now here comes the main part. Turbo yeast is something artificially and chemically prepared yeast which inbuilt contains yeast and nutrient. So other than yeast and nutrients, there are some different chemicals added into it, and yeah, the statistic will make you more understand that what happened in throughout the process. So this was the phase 3. In phase 4, we were done by the mid, like before the study break, but then we came up with this idea that we should make the duplicates. But after that, we came to know that it is compulsory. It was not an idea, because to compare the previous samples, previous sets, and this set, that can give you a good ratio that was there any contamination, because maintaining 9 to 12 samples and taking readings every day, like not every day, but after whatever the time duration was, but twice a week. So there could be high chances of making contamination. And the main contamination in our project was if the sample comes into the contact of oxygen for a long time, it can get contaminated. So it can stop the process and it can convert into directly to the water. So that was the phase 4 preparation of duplicates. That was the main part which gave us the confidence to provide you the statistics further that it was a success in our process. Phase 5 was the measurement. I won't say it phase 5, but I would say that from the preparation of phase 2, we started the readings. Now the readings were hydrometer readings, which we did in the semester 2nd in petrochemical course. And there was bricks reading also. The weaker student will take it. You will come to know that we made gummies in our natural health product labs. We use the bricks to check the sugar level. Now these two factors, these two analytical instruments helped us very much, and I will give you a short intro what and why we were using this. Hydrometers are for the density. They shows that is our process converting into ethanol, because if you check the water density, less is more as compared to ethanol density. So hydrometer were used for the particular thing. Now talking about the bricks, so the sugar level. As soon as we start the fermentation, so if for example you keep fermentation today and if you check after 2 days, you will see a sudden decrease in the sugar level. That shows that the process has been started. Because the main thing is for different type of yeast, there are different procedure to activate the yeast. In our case, we use the lalveal yeast. It's lalvin yeast used for wine process. That is what we used, and it takes 30 degrees Celsius and half an hour of heating to get activated. So that was our phase 5, and in phase 6, in the last 2 weeks, we are doing our statistical things, ANOVAs and everything. So this was the work plan. And I would like to call Diptis to talk further about the difficulties faced.
Hello, I would like to discuss some difficulties which we faced during that 3 months, and I know that everyone faced somewhere and somehow some difficulties, and everyone learned something from that difficulties. But whenever the word difficulties come to my mind, there is one nice word come to my mind, which is in the middle of difficulty lies opportunity. So whenever you feels like difficulties, you can get one nice way. In the same way, when we started our project, we were decided to keep all that sample inside the oven. But after we got to know that there was not enough space inside the oven, so we kept all that sample inside the lab. But we put some safety data sheet and everything, so everyone get to know, and we try to maintain the temperature level, because yeast is microorganism and it is necessary to keep temperature maintained. The second one is contamination risk. So we try to keep all the utensils and all the flask, everything away from contamination, and we try to wash all the equipments with the water and the soap after using. Third one is complex experimentation, because we just got 2 results, one of bricks by refractometer and one is density by hydrometer. So it is little bit confusing to figure it out how much amount of alcohol we got. But we got little bit of guidance by Mr. Steve and Margaret. So and we use some online articles, and we came to know, and the calculation of ethanol percentage. Here I would like to discuss some changes we made throughout our plan. So first one is we were supposed to use fermentation log, but into first 2 weeks we didn't got fermentation log, and as we learn into school, so we can use balloons top over the flask. As you can see into the first figure, we use balloons instead of fermentation log, which make some medium, like it don't allow oxygen to come inside the flask, and carbon dioxide, it holds carbon dioxide. The second one is GC instead of alkalizer. We were supposed to use alkalizer, but into the end, like our professor suggested us about alkalizer, but when we collect all the sample and we got to know that it's not enough amount for alkalizer. So again we came to GC, but we didn't find any spot for GC, so Miss Margaret analyzed all the sample for us. Third one is introduction of turbo yeast. So we were supposed to work with different parameters like temperature, pH, and different nutrition. But Miss Margaret told us about turbo yeast, and we use that yeast which comes with nutrition, and it can enhance the rate of speed. The last one is advancements, and now Syama will get you.
So about the statistics of the data, we have already prepared 18 samples in which we had 9 replicates and 9 were the original samples. Those 9 samples were like each of 3 sets, and these are the sets we prepared. It's like we had 3 samples in which we study about the effect of the amount of sugar in the alcohol production, and 3 samples with which we study the effect of yeast nutrient. The yeast nutrient we used in our study was the ferment K, which gives the potassium, which is a very important nutrient for the yeast to perform the anaerobic respiration of the yeast. So we introduced that yeast nutrient to the samples, and there were 3 sets of samples in which we studied the effect of turbo yeast. As Manish mentioned, turbo yeast is an advanced developed yeast which has built-in nutrients in itself. So I'll give you an overall comparison of the ethanol that we have produced from each of our samples using ANOVA 2K, and all these 3 sets we will be discussing the Brix reading and hydrometer readings, which the trend followed by those readings in our daily the data we collected on our lab days. So moving on to the effect of amount of sugar, as we know, Brix calculates the concentration of sugar present in a particular sample. So as the concentration of sugar increases, we can increase the amount of Brix value also increases. Since we have this 25 grams sugar, we had a less Brix value, and as we increases it to 75 grams of sugar, the Brix value increases. And as the days go by from 1, 13, 15 and 29, as the days go by, the Brix value is reducing, which indicates that the sugar is consumed during the fermentation process by the yeast and it is converted to the ethanol. And in the hydrometer reading, we measures the specific gravity or the density of the solution sample that we have prepared by the fermentation, and we have a original specific gravity and a final specific gravity which we mention at the end of the process, like after 29 days, and we are calculating the ethanol percentage from it by subtracting the original gravity from the final gravity from the original gravity and multiplying it with a constant value, which gives you the ethanol percentage. That is what we came up with the brewer's calculation process, because we were not able to analyze the ethanol percentage using GC. We didn't got a slot for that. So in this hydrometer's reading, we can see that as the sugar concentration increases, hydrometer reading also increases. It's like the hydrometer reading for a pure water is 1.000, and for ethanol it will be like 9.000. So sorry, 0.900. So in that case, as the amount of sugar increases, it goes from 1.020 to 1.060 as the sugar concentration increases. And as the days go by, the hydrometer reading that the specific gravity is getting down from 1 to 0.9, which indicates the presence of ethanol. And in the ANOVA, which we performed for this 3 sets of experiment, we have got a p-value of 0.002, which is very less than the significance level that we have performed, that is 0.05, indicates that there is a significant difference in the experiments that we have studied using different amounts of sugars. And the best method when we compared with the Chuki was using high amount of sugar for the ethanol production, so that we can yield more amount of ethanol from it. And these two values, these two experiments are statistically different. And here is the effect of yeast nutrient in this. We have studied in the same way. We have taken Brix readings and the hydrometer readings on every lab days. So we had 1 to 24 days, both of the readings. And as we checked the readings at the beginning, it was constant, both the hydrometer reading and the Brix values. It is because we are studying these results for 50 grams of sugar, and we are comparing different amounts of yeast nutrients, that is 0.5 grams of yeast nutrient, 1 gram of yeast nutrient, and 1.5 grams of yeast nutrient. We are changing the amount of nutrients in it, keeping the amount of sugar constant. That's the Brix value, and the hydrometer value was a constant at the beginning. And as the process goes on, the amount of sugar converted into alcohol is increased, and there is a drastic drop in the Brix and hydrometer reading of these two values, because we are using high amount of nutrients in it, which helps the yeast to process faster compared to a low amount of nutrient. And we can see there is no significant change from this to this, which indicates that there should be a particular ratio with the yeast and the nutrient, which indicates that if the amount of nutrient is higher but the yeast is less, the efficiency of yeast may decrease. That's why there is no much difference in that. In case of the ANOVA that we plotted for these 3 experiments, we have got a p-value of 0.045, which is again less than the significance level that we have opted for, and that the best method by this method is like the 1.5, using higher amount of nutrient. So, and when we are comparing the turbo yeast, same thing is following here itself, and there is a drastic difference between the first initial state and final state, but there is a continuous change here, which indicates that since it's built-in nutrient, there is no significance between the ratio of nutrient and the yeast. We have to just add the yeast in different quantities, that it is. And when we study the ANOVA, this gives the best method for this one is using high amount of turbo yeast. So in any case, if you are using higher amount, we'll get higher amount of ethanol, and if you are increasing the turbo yeast, we can get it in a easy and less timely manner. And this is the overall comparison of our entire experiment with 9 samples which we have studied. In this, we have got the 75G and this one, and also this one, having a higher amount of ethanol in it, which indicates that as we provide nutrients, it can increase the fermentation process, which will lead you to get more ethanol. And also, when we are increasing the concentration of sugar or the amount of sugar present in the sample, that can also lead you to the increased amount of ethanol. And the best method for this is obviously using the turbo yeast, and these, as we know, with just using yeast and using turbo yeast is statistically very different, and these are the 2 values of those 2 experiments performed. And I'll ask Ms. Khan to just discuss about the future aspects of our experiment.
Hello everyone. Now let's quickly move to the future aspects of this experiment. So as we all know that in this contemporary era, the usage of technology has been increasing so rapidly, and it also makes everything very easy. No matter if you are studying anything, no matter if you are working on any certain field, if you know that how to use machinery, technologies, and if you know the knowledge of that particular field, you can ace it. So, as according to our project, these are the studies which I specifically mentioned here. If you really want to know more about bioethanol in any certain field, you can do these studies. These are nothing, just these are the three basic studies. No matter if you are from mechanic background, if you are from bio background, or if you are from engineering background. If you can join your previous study with analytical chemistry, you can work on it. So the first one is mechanic studies. In the mechanic studies, as its meaning mention itself, the mechanics. So by this way, you can know about how things work mechanically, how the metabolic pathway and mechanism of yeast will work to know the fermentation. Now, this include advanced techniques. As I already mentioned, that if you are working on a large scale, you will get more resources, more technology, and more machinery to work on it. So these including more techniques like use molecular biology and metabolism for in-depth analysis. To know more about the thing, you can work on it. The second thing, and the nutrient optimization, as these including nutrients and the concentration of nutrients. Now the second thing is genetic engineering. It's basically genetics, which is biology. So those who are from biology background, as I am, we can also work on it. So in this, we basically genetically modify the enzyme and the yeast strain to enhance our fermentation process to get ethanol. So the last one is process engineering. So as I already mentioned to you, that if we want to work on a large scale, we'll get more resource, more thing to work. So these will improve our product quality as well, and also we can explore new bio-based products by using various feedstocks. So now let's quickly move to the conclusion. As already my friends mentioned that what problems we have faced so far and how much samples we made. So this is all what they already mentioned. So I just want to be more precise in this particular slide. That there are so many up-down we faced so far in these 10 weeks, but still somehow we managed to do, to get what we actually planned to get. So these are some things you already know about this. And now if you actually want to know more about what we did, you can go to the references. These are the references available and you can work on it. So if you want to ask any question, you are more welcome to ask.